section 6. In chapter 5, you talked about, or you looked at, I hope, graphs of all the trigonometric functions. And again, it's a good idea, in fact, it's going to be critical, that you're familiar with the generic graphs for at least the sine, the cosine, and the tangent functions. You can find those in section 5 or on the back cover. Now we're going to actually just consider variations of the sine and cosine functions. Okay, actually I'll put an E on the end of that. All right, first of all, we're going to look at graphs in the form of y equals capital A sine bx minus c plus d, and y equals a cosine bx minus c plus d. Okay, these are the forms of the graphs that we are going to look at. And don't forget that a, b, c, and d are constants. And what each one of these is going to do is it's going to tell us a story about how to take the generic sine or cosine graph and either stretch it or shrink it or stretch it or shrink it or move it, okay, transpose it around the coordinate plane, okay? So let's look at what each constant does to a graph. And we're going to start with the constant d, all right? First of all, the constant d translates the graph vertically. Okay? Now, the graph goes up d units if d is greater than 0. And it translates the graph down d units if d is less than 0. Now, notice it doesn't say greater than or equal to, less than or equal to. It says greater than or less than. If d is 0, it doesn't move at all. It stays put, centered about the origin in terms of vertical, okay? So, for example, if you had a sine graph, and I'm not going to put the coordinates on here at this point. I don't want to spend too much time. Actually, let me label this sine of x. Then, if we had y equals sine x plus 2, it'd be the same graph, except it would be moved up 2 units, okay? So d translates everything vertically. A, the constant a, stretches the graph vertically. Okay? So the idea here is, if the absolute value of a is greater than 1, there is a vertical stretching. If the absolute value of a is less than 1, like a decimal, because don't forget absolute value is always positive, so you're probably thinking how can it be less than 1? It could be a decimal. If the absolute value is less than 1, there's a vertical shrinking. Okay? And if a is less than 0, not the absolute value, but a itself, the graph is also reflected across the x-axis. Okay? Now don't forget that the amplitude of a graph, or sine or cosine graph, or function, is the absolute value of a, okay? I am sure that on your next exam, I'm going to give a question where it asks you, it gives you a function, and it asks you to find the amplitude, the period, and to graph it, and to tell me how it's going to behave when it's in the form of this or this, okay? I'm positive that this will be on your next exam, and it's likely it'll be on your final. I haven't written your final yet. So make sure you know how to find the amplitude. It's just the A, the absolute value of A, okay? So for example, if you have, again, I don't want to spend too much time drawing the graph out. If you had a sine graph, and we had the function y equals 2 sine of x. Well, this is 1, this is -1. What 2 means is we stretch it 2 in both directions. Actually, that's not a bad line. Okay, so it's still going to be centered at the origin. You're just stretching it. And it's still crossing at the same points on the x-axis. You're just stretching it vertically, okay? So again, make sure you know how to manipulate that. The other variables, again, the text does a pretty good job of explaining what those are, how those behave. You also, okay, so actually let me just go through them. It's just easier to go through them. Let me erase what I have here. Okay, so the constant b tells you what your horizontal stretching or shrinking is going to be. And this horizontal stretching or shrinking is called the period of the function. Again, I am sure that there will be a test question that asks you to find the period of a function, the amplitude of a function, etc., etc. Okay? So again, if you had just really quickly, a sine function that's nice and easy. And for example, we had sine equals, okay, so the period of this is 2 pi, okay? If we had y equals sine of 4x, okay, the idea would be, actually that doesn't go high enough. The idea would be that it cycles through this 4 times for every 1 time the other graph cycles through. This is an awful, awful, awful example. But the idea is it shrinks it so it cycles through 4 times instead of just once for every time that a regular graph cycles through. Okay. Just as a note, you can actually find the period of the graph fairly easy just by looking at the function. The period is 2 pi divided by b, where b is your constant right here before the x term. Okay? 2 pi divided by b. In the text, it gives you also a formula to calculate the period of the tangent and cotangent graphs. The period would be the absolute value of pi divided by b. It's a little bit different. And then the period of your secant and cosecant graphs would be, again, 2 pi divided by b. And these are all periods for each graph, which again is how often it cycles through compared to a regular graph. All right, now, the variable c, or the constant c, is your horizontal translation. Which is how far you move the regular graph to the left or to the right, okay? The translation is c units, the absolute value of c units, okay? There is a wonderful summary in this section on page 559. There's a box that goes through the transformations of the sine and cosine functions. There's an example, too, that's really neat to follow. Then, what would probably help to prepare you for your exam is the visualizing the graph on page 565. So let me give you the answers to that as well. To be able to pick out your constants, your function, and to know how those constants affect the graph. Okay, so the answer to number 1 is J. The answer to number 2 is H. The answer to number 3 is E. The answer to number 4 is F. The answer to number 5 is B. The answer to number 6 is D. The answer to number 7 is G. The answer to number 8 is A. Number 9 is C. And number 10 is I. And again, this is the visualizing the graph on page 565. There's a great chapter summary. This is sort of a big chapter and there's a lot going on. There's a wonderful chapter summary that I would certainly go through and make sure you understand everything in it on page 569. It gives definitions, it gives pictures, there's a unit circle example in there too, I think, or at least I saw a unit circle. Yeah, I see the unit circle and some explanation there. This is, again, just a pretty big chapter, so it's important that you sort of take your time and walk through it slowly. And if you have any questions, as always, feel free to email me.